This is SpaceTime Series 27, Episode 109, for broadcast on the 9th of September 2024. Coming up on SpaceTime, how Venus got its continents, propulsion glitches aboard the BepiColombo's spacecraft, and the Sentinel-2C's spacecraft joins the Copernicus family in orbit. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims geologic features on the planet Venus, known as tesserae, may have formed in the same way as Earth's earliest continents billions of years ago. The findings, reported in the journal Nature Geoscience, are based on high-performance computer simulations as well as data from NASA's Magellan spacecraft. The results suggest that Ishtar Terra and other tesserae on Venus may have arisen from the planet's hot interior through a process very similar to the formation of Earth's cratons, the ancient cores of continents. The study's lead author, Associate Professor Fabio Capitano from Monash University, says the study challenges science's current understandings of how planets evolve. Capitano says he didn't expect Venus, with its scorching 460-degree surface temperatures and lack of plate tectonics, to possess such complex geological features. And so these findings are providing a fascinating new perspective on the planet Venus and its potential links to the early Earth. The features found on Venus are strikingly similar to the Earth's early continents. That suggests that the dynamics of Venus's past may have been far more similar to Earth than previously thought. Earth's cratons hold crucial clues about the emergence of topography, atmosphere, and even life on this planet. Capitano says understanding how these continents formed on Venus could shed fresh light on the evolution of all rocky planets, including the Earth.
We call it comparative planetology. So we take different planets that we know of and we compare them, we see how close they are and how distant they are, meaning in their evolution. So we knew somehow that Venus had to be sister planet, had to be similar, one of the closest to Earth. But of course, there is a big question there at which point during the evolution we got different paths, because all the planets eventually they have the same age. Venus is the same age of the Earth, so it went through the same maturation, but ended up in a different pot. Obviously, not a nice one, as you said. It's not really a lively place. So at that point, to understand how we got there, and so the rocks out there, the third rock from the sun became the Earth, whereas Venus didn't. So it's much better to put it in the context of the evolution. And when we talk about the evolution, of course, we compare it with the evolution of the Earth, which is so far the only one or the best known, and we compare them. So we got back in time and we had a look at, in the past in my research, we had a look at how continents are formed on Earth, and we did some work on it. And in the process of understanding how continents work, of course, the question was how is this possible at all, and if it's possible, must be possible somewhere else, some other planet. So we had to look at Venus path, and we changed our simulations. So we used fundamental physics solved with supercomputers. We changed the parameters, the surface of the temperature of the surface, as you mentioned before. A little bit of this, a little bit of that. So all the ingredients, they make the tiny ingredients that make the difference between the Earth and Venus. And what came out was essentially using the same mechanism we used to understand continent formation here, we got to understand also the condition on Venus that lead to the formation of these plateaus. So they're called plateaus, but on Earth plateaus are something different. But turns out that those plateaus are just like continents on Earth.
When we look at the continents on Earth, the prevailing hypothesis, and there's a fair degree of evidence to back that up, is that it's basically convection. We have continental plates, they move across the surface, they come up at mid-ocean ridges. The light stuff, the granitic stuff, floats on top, that becomes the continents, and the heavier stuff, the basaltic stuff, that eventually subducts again back into the mantle. There are other things going on as well, such as cratons and that, hotspots and things like that, but that's the primary driver, as we understand it, of plate tectonics and continent forming here on Earth. Venus being so hot, the current theory is that plate tectonics never occurred on Venus.
Yes. Well, that's the point, but not only, also on Earth. it's still debated whether when plate tectonics started, because as you said, continents are the result of plate tectonics, but a lot of questions are out there. So cratons, as you were talking before, they are formed by magmatic processes that they extract the lightest material from the mantle to form continental crust and continental lithosphere. The point is that they only formed in a period of the Earth and didn't form when we know the plate tectonics was operating. So this raised the question, if plate tectonics is the only mechanism we know, and it doesn't create continents, so either we stretch the theory of plate tectonics to include formation of cratons, and that didn't work, or otherwise we have to admit that the Earth had probably a regime that wasn't a plate tectonic regime. So the work that we've done a few years ago was published on Nature too, on the formation of cratons is just showing the formation of cratons, as you were saying before, from convection, but not necessarily plate tectonics. So you need convection, you need the thinning of lithosphere and melting, and that melting will create a lot of continental crust, and the continental crust eventually stays there, as opposed to current plate tectonics, in which every 200 million years material is recycled.
What causes cratons? What makes a big chunk of the mantle decide to suddenly rise up to the surface? Is that simply the chemistry involved and the temperatures and pressures involved that allow these things to expand upwards? Or what causes them?
Well, as you said before, it's one of those ingredients, and to our understanding, the key ingredient would be the temperature. We know that the Earth's mantle was hotter in the past. And when the mantle is hotter, it simply means that the lithosphere that sits on top is a little bit more squishy or sluggish. It moves a little bit more, it's a bit more prone to deformation. And this fact induces the lithosphere to stretch a lot and allow hot mantle to come up closer to the surface than today. And when it comes closer to the surface, it undergoes what is called decompression melting. So essentially it's very hot, reduces the pressure and melts. This, of course, imagine that would have been the regime of the whole planet. It would have created a lot of these large portions of this mantle decompressing and creating crust. But the point is also that this melt extracted from the mantle leave the mantle depleted. And when it's depleted, it becomes stiffer and becomes lighter, like any material that is devoid or depleted of some component. Imagine a sponge that is depleted of the water, you're left with the sponge itself, which is inherently lighter. So that's the mechanism that could have worked under those conditions, because the Earth was hotter, and then eventually with secular cooling, that condition vanished. Mantle became cooler and cooler, and that amount of melting is not possible anymore. And this, at that stage, it's where we think plate tectonics would have started.
Of course, the surface of Venus, 460 degrees Celsius, is still very hot and malleable.
Yep.
You've looked at Ishtatera, one of the continental tesserae, and you've focused on that. Tell me about that.
Yeah, of course, it's an amazing. We had a look at how this continent forms on Earth, and the point of the continents is that because, as you say, they have a crust, the continental crust, which is inherently lighter because it's extracted from the mantle, and because it's lighter and buoyant and thick above the sea level, whereas the basaltic crust on this planet, it's heavier and sinks. So if you don't have this dichotomy, if you don't have this basaltic crust versus granitic crust, how do you create topography in the first place in places like Venus? So that's what captured our attention. So we said, okay, if continents on Earth are the places that where elevation increases and that led eventually to conditions for life, it must be the same on Venus. So they are above these plateaus, these elevated areas. They are standing above the average radius of the planet because they must be lighter. And if they're lighter, we have to find a mechanism that creates them. So we had a lot of observation and a lot of work that was done interpreting those observations, but so far we never had a forward model. So a model that starts with fundamental principles of physics, the physics that we use in geology, and then eventually leads to the formation of these plateaus. So eventually we came to the conclusion that yes, we don't have an ocean here, we don't have a basaltic crust, but those areas, they have a thick, lighter crust formed in the same way of cratons, and eventually they pop up.
So cratons is it?
Yeah. Yeah. Besides, as I say, we have to change name because we call those on Venus plateaus, but plateaus on this planet are places like Tibet. So we probably should call it rather than Ishtar Terra Plateau, Ishtar Terra Craton.
There are some features on the surface of Venus that we just don't see here on Earth.
No. There's many out there. One of those is volcanoes that are incredibly taller on other planets than on Earth. The same itself, the same Ishtar Terra, that's why it captured our attention, it is called a plateau, but if you think about it, it's as tall as the Himalaya, as the Tibetan plateau, has some bordering mountains that are as tall as the Himalaya and even taller, so the Maxwell Mons reaches up to 13 kilometers as opposed to the less than 9 of the Himalaya. So you can imagine how tall it is. And also the size of the width of that plateau is essentially as big as Australia. So it's we don't see such big, incredibly big continents formed in the same way because also Australia is quite big, doesn't have the topography, and Australia is just a puzzle of different pieces. So they don't fall together like happen on Venus.
Where do you take this research to now?
This research we do in the evolution of the planet compared to the Earth has an obvious application. If you consider that the evolution of our planet led to the condition for life, the way we understand whether there is life on other planets is essentially looking at their tectonic evolution.
That's Associate Professor Fabio Capitanio from Monash University. And this is SpaceTime. Still to come, a propulsion glitz aboard the BepiColombo's spacecraft, and the European Space Agency's Sentinel-2C spacecraft joins the Copernicus family in orbit. All that and more still to come on SpaceTime. Mission managers on the BepiColombo's spacecraft are working to resolve a problem which has been affecting the spacecraft's thrusters. The issue is preventing the thrusters aboard the joint European Space Agency Japan Aerospace Exploration Agency probe from operating at full thrust. BepiColombo is a 3-part spacecraft. It consists of 2 science orbiters, ESA's Mercury Planetary Orbiter and JAXA's Mercury Magnetospheric Orbiter, as well as a cruise and propulsion stage known as the Mercury Transfer Module. The 2 scientific vehicles are designed to separate from one another during Mercury orbit insertion, allowing them to investigate different aspects of the planet from different orbits. The solar arrays and electrical propulsion systems on the Mercury Transfer Module are used to generate thrust during the spacecraft's complex journey from Earth to the nearest rock to the Sun. However, on April the 26th, as BepiColombo was preparing to begin its next orbital manoeuvre, the transfer module failed to deliver enough electrical power to the spacecraft's ion propulsion thrusters. Eventually, engineers identified unexpected electrical currents between the Mercury Transfer Module's solar arrays and the units responsible for extracting power and then distributing it to the rest of the spacecraft. Technicians were able to restore about 90% of that power by May the 7th. But they've failed to achieve full thrust. Mission managers have now developed a workaround to account for the spacecraft's reduced power. The new trajectory maintains the baseline scientific mission, but allows the spacecraft to use lower thrust settings during the cruise phase of the mission. With this new trajectory, BepiColombo is now expected to arrive at Mercury in November 2026. That's 13 months later than originally expected. The BepiColombo Flight Control Team's current priorities are to maintain stable spacecraft propulsion at the currently available power level, and to determine how this will affect future operations. The good news is BepiColombo did arrive at Mercury in time for its 4th gravity assist flyby around the planet last week, swooping down at just 165 kilometres above the Mercurian surface. The close encounter took BepiColombo closer to Mercury than it's ever been before, in the process reducing the spacecraft's speed and changing its direction. It also gave mission managers a chance to snap some amazing images of the planet and fine-tune science instrument operations before the main mission begins. BepiColombo was launched in October 2018. It's on a trajectory that makes use of 9 planetary flybys. These include 1 of the Earth, 2 of Venus, and 6 of planet Mercury itself. These are all needed to help steer the probe into orbit around the planet. BepiColombo's fifth Mercury flyby will occur in December, followed by a sixth in January. After that, the probe should be able to achieve Mercury orbit insertion. The planet Mercury is the least explored planet in the inner solar system. It's mainly because getting there is a real challenge. See, as a spacecraft gets closer to the Sun, the powerful gravitational pull of our local star tends to accelerate that spacecraft towards it. Now add to that the fact that any spacecraft launched from Earth already has lots of energy needed to escape Earth's gravity, it winds up travelling much too quickly to be captured in orbit around little Mercury by itself. To overcome these hurdles would be enormously difficult using just onboard thrusters. So BepiColombo also makes use of gravity assist flybys. These help it lose energy and slow down enough to eventually be captured by Mercury's gravity and enter orbit. 10 of BepiColombo's 16 science instruments were operational during last week's flyby. That gave scientists a chance to taste the sort of discoveries they can expect to make once the main mission begins. Magnetic, plasma and particle monitoring instruments sampled the environment before, during and after the closest approach. Other instruments couldn't be operated because their fields of view were blocked by the Mercury transfer module. Testing out the instruments during flybys provides a valuable opportunity for science teams to check their instruments, make sure they're functioning properly and that they've been calibrated correctly for the main mission. Now sadly, BepiColombo's main science camera will be shielded until the ESA and JAXA orbiters separate. But during the flybys, images have been taken using 3 monitoring cameras on the Mercury transfer vehicle. These are providing black and white snapshots. The cameras are actually designed to monitor the spacecraft's solar arrays, its antenna and its magnetometer boom, especially during the challenging period after launch. Last week's flyby was also the first to take BepiColombo over Mercury's poles, helping to adjust the spacecraft's trajectory to match that of Mercury, which is inclined compared to the Earth's orbit. The images include the first ever stunning views of the planet's south pole. Others reveal large craters, wrinkle ridges and lava plains, all of which are helping scientists better unlock the secrets of Mercury's 4.6 billion year history and its place in the evolution of our solar system. This report from ESA TV.
Allumage 2AP, décollage.
The BepiColombo mission to Mercury is off to a successful start. Within hours of launching from the European spaceport in French Guiana, the spacecraft had unfurled its antennas and 2 15-metre solar arrays. Monitoring cameras even took some selfies, showing one of the solar panels and 2 antennas. A few days later, the spacecraft deployed a 3-metre boom containing sensors to record magnetic fields. Images from the NASA Messenger mission are the best we have of Mercury. It has highlands and lowlands like other planets, but unlike Earth, Mercury rotates on an axis perpendicular to its orbit.
Due to the fact that Mercury is not tilted, there are some craters on the poles where the sun never shines into it. And inside these craters, Messenger found water ice. It was detected even earlier in the 80s from ground that there were rather bright spots and there were some hints that it might be water ice. But now from Messenger, we are pretty sure that we have water ice in craters. And that's pretty much surprising. Think about it. You have a planet on the surface 450 degrees and then you have water ice at the poles. It's kind of unbelievable.
Fortunately, there's an instrument on board called MERTIS, which can measure the surface temperature directly to see if it's cold enough for water ice. Knowing the makeup of the planet's dark surface is also important. A team at DLR, the German space agency, have built a special chamber to heat up samples to examine how they behave at high temperatures. These can then be compared with what will be found on the planet. Planetary scientists are unsure how it formed. It could have originated beyond Mars, with an impact pushing it closer to the Sun. Or it could have formed at lower temperatures in its current position. If so, current theoretical models will need a rethink.
And one of the things why I like working on Mercury is we need to understand Mercury in order to understand how planets form. If we have a model that forms all planets but not Mercury, that model is basically useless because you need to get that one as well.
NASA's Messenger mission did a great job, but BepiColombo consists of 2 orbiters using complementary orbits with more combined instruments. Plus, unlike Messenger, it will obtain high-resolution images of the entire planet. The planet is also shrinking in size, possibly due to cooling. Plus, there may be active volcanoes, so there is much more to learn.
Mercury is a very mysterious planet. Every time we went there, we found new surprising results. And that is the reason why we do BepiColombo. And we hope with BepiColombo, on one hand, we are able to answer many of these new questions. But I'm pretty sure we found a lot of new surprising results which raise new and other questions which we then need to follow up.
And in that report from ESA TV, we heard from BepiColombo ESA project scientist Johannes Benkoff and DLR planetary scientist Johan Hilbert. This is SpaceTime. Still to come, Sentinel-2C joins the Copernicus family in orbit following a successful liftoff, and later in the science report, a new mega study confirms what we've been telling you for years. Cell phones don't cause brain cancer. All that and more still to come on SpaceTime. The third European Space Agency Sentinel-2 satellite has been successfully launched into orbit. The flight was aboard the very last Vega rocket from the European Space Agency's Kourou spaceport in French Guiana.
We have a fixed launch time today. We don't have a launch window. We're live at the European spaceport in French Guiana for the launch of Sentinel-2C. Our very best wishes to all the teams.
Go Sentinel-2C.
4, 3, 2, 1, top. Allumage P80. Allumage P80, décollage.
They're off. Sentinel-2C and Vega are blazing a trail across the equatorial skies here over Europe's spaceport in French Guiana, heading north out over the Atlantic towards the Caribbean islands, burning the first 3 stages. The first stage, of course, burning now, getting us away from the gravity of the Earth. Vega really shoots into the sky, Damien, doesn't she?
Yeah, it does, and we could feel the rumble tumble here in the commentary cabin. So the P80 delivers a powerful thrust about 230 tons, equivalent to twice its weight. It just results in a very rapid acceleration. So the first stage, its mass in propellants is 89 tons, and it is made of a special material called filament wound carbon epoxy.
And separation there of the P80 first stage and switch on of the second stage, the Z23. So at this point in time, we've lost about 2/3 of our weight, and we're hearing that the propulsion is nominal and the trajectory is nominal. And of course, the idea is to get rid of mass when it's no longer needed.
As soon as each solid stage has used its propellant, yes, we jettison it. So that's why we split a rocket into different stages to avoid dragging unnecessary mass into space.
And we're burning the Z23 second stage, Z for Zafiro, which is a type of wind, a gentle and favorable west wind.
It is often associated with bringing spring and good weather. It very much aligns with the goal of the Vega launcher, which aims at providing reliable and efficient access to space. So, Katie, it's a poetic note to the idea of a smooth and successful journey.
And we're getting news there that coming towards the end of the burning of the Z23, our altitude 113 kilometers above the Earth, traveling at nearly 4 kilometers per second. Separation there of the second stage, and there's a short delay before we then get the ignition of the third stage. That's to avoid any collisions up in space. And we have separation now of the fairing. That's been jettisoned. We don't need it anymore. And we've got the switch on time. Now this is the scheduled moment to switch on the engine of the Avum upper stage. We have that confirmed. This is an important moment, actually, in the flight. Trajectory is nominal, we're hearing. We've really started the next phase now of this part of the journey because the Avum or Avum has taken the wheel and its job is to deliver our passenger to its required orbit.
Yeah, and we've got confirmation.
We have confirmation, yeah.
Deuxième allumage de l'Avum.
We have a switch on of the second boost for the Avum upper stage. It's switched its engine on again for the second time. All going according to plan, all nominal. Coming up now on Avum cutoff.
Deuxième extinction de l'Avum.
And we have confirmation there. Second switching off of the Avum upper stage, confirmed. We're on the targeted injection orbit required for Sentinel-2C. The separation actually is going to start pretty soon now in a matter of seconds, and he's telling us that the orbit is completely nominal.
Début de la manœuvre d'orientation au profit de Sentinel-2C.
Beginning of the orientation maneuver, getting Sentinel-2C ready to be released onto its orbit.
Séparation Sentinel-2C.
We have separation there of Sentinel-2C. That's good news. We are looking at happy faces in the Mission Control Center here, Jupiter Mission Control Center.
Sentinel-2C will provide high-resolution data as part of the Copernicus Earth Observation Program, monitoring climate change and environmental challenges globally. It'll ensure the continuity of vital data in support of agricultural, forestry, maritime and pollution monitoring. Two previous Sentinel-2 satellites, Sentinel-2A and Sentinel-2B, were launched back in 2015 and 2017 respectively, both using Vega rockets. Sentinel-2C marked the final liftoff for the Vega rocket. All future Vega launches will now use the new upgraded Vega C. The Copernicus Sentinel-2 mission provides high-resolution optical imagery for land, water and atmospheric monitoring. The mission is based on a constellation of two identical satellites flying in the same orbit 180 degrees apart. Now currently they're Sentinel-2A and Sentinel-2B. Together they cover the entire planet's land and coastal waters every 5 days. With Sentinel-2C now in orbit, it'll soon replace its predecessor Sentinel-2A following a brief period of tandem observations. Eventually a fourth satellite, Sentinel-2D, will be launched to take over from Sentinel-2B. Later it's planned that the Sentinel-2 Next Generation mission will ensure data continuity beyond 2035. The current Sentinel-2 satellites each carry a high-resolution multispectral imager which generates optical images in the visible, near-infrared and short-wave infrared part of the electromagnetic spectrum. From their 786-kilometre high orbit, they provide continuous imagery in 13 spectral bands with resolutions of 10 metres, 20 metres and 60 metres and a wide survey width of 290 kilometres. Sentinel-2 data is currently being used for agriculture, water quality monitoring and natural disaster management, including wildfires, volcanic eruptions and floods. The mission's already surpassed its original expectations by demonstrating its ability to detect emissions of the greenhouse gas methane. For agriculture, the mission helps monitor crop health, it predicts yield outcome and it enables precision farming. The images are being used to detect crop type and to determine biophysical variabilities such as leaf area, leaf chlorophyll content and water content in order to monitor plant growth and health. This report from ESA TV.
Sentinel-2 is based on a constellation of two identical satellites, Sentinel-2A and Sentinel-2B. They both fly in the same orbit but apart to optimize coverage and revisit time. The satellites carry a high-resolution multispectral imager and generate optical images from the visible to the short-wave infrared region of the electromagnetic spectrum. The constellation was originally designed to monitor land surfaces, but its scope has since expanded. It now covers a wide range of applications. This includes land cover changes like deforestation, agricultural monitoring, and mapping variables like leaf chlorophyll, leaf area index, and water content. It also monitors water quality, changes in water bodies, and coastal erosion. It has witnessed icebergs breaking, glaciers retreating, ice sheets melting, changes in sea ice, and variations in snow cover. It has even spotted penguin poo from space, helping monitor emperor penguin colonies. Sentinel-2 has also proved useful in monitoring natural disasters like wildfires, earthquakes, volcanic eruptions, floods, and landslides. These data feed into the Copernicus Emergency Management Services and the International Disasters Charter, providing essential imagery to support local teams. The Sentinel-2 mission even went above and beyond its original expectations, demonstrating its ability in detecting methane emissions. Sentinel-2C will replace the Sentinel-2A unit, prolonging the life of the Sentinel-2 mission and ensuring a continuous supply of data for Copernicus, the Earth observation component of the EU space program.
This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A World Health Organization commissioned systematic review of the potential health effects of radio wave exposure has found that cell phones are not linked to any head cancers. The findings, reported in the journal Environmental International, looked at over 5,000 individual studies. Of these, 63, which were published between 1994 and 2022, were included in the final analysis. Scientists found that although the use of wireless technology has massively increased in the last 20 years, there has been no increase in the incidence of brain cancers. The study was led by experts from APANSA, the Australian Radiation Protection and Nuclear Safety Agency. A new study claims that more than a third of the world's fish species never received an extinction threat classification simply because scientists don't know enough about them. Now researchers are using artificial intelligence to try and predict which of these thousands of data-deficient species are most at risk. A report in the journal PLOS ONE quintuples the number of species in the threatened category, with Australia's west coast and many Pacific islands being hotspots for the need for protection. Paleontologists have described a new species of dinosaur which roamed the Iberian Peninsula 75 million years ago. Fossils of the 6-metre-tall Quincunsaura piniquiniestra were discovered during construction works on one of Spain's many new high-speed rail lines. A report in the journal Communications Biology claims the late Cretaceous era ceropod is one of the most complete skeletons ever found in Europe, including cervical, dorsal and caudal vertebrae, as well as part of the pelvic girdle and even elements of the limbs. Ceropods are those large herbivore dinosaurs similar in appearance to Fred Flintstone's pet Dino. They have large elephant-like bodies and legs, a long tail at one end, and a long neck and small head at the other. Well, it sounds like something out of the X-Files, but a group of scientists are seriously proposing that some UFO sightings could be a secretive population of advanced dinosaur humanoid beings that evolved from velociraptors. Because of their large brains, senior paleontologists have long speculated that had the warm-blooded velociraptors survived the extinction of non-avian dinosaurs 66 million years ago, mammals might still be shrew-like creatures scurrying around the forest floors. You see, the size of Velociraptor's brain in proportion to its body is relatively high, especially compared to most other reptiles, including most other dinosaurs, so it seems likely it was comparatively clever. And that raises the possibility that, had they survived, they might have eventually evolved into a species of intelligent humanoids, filling the same ecological niche as Homo sapien does today. This so-called dinosauroid was a serious hypothetical study based on the evolution of Homo sapiens, looking at what Statonichosaurus raptors might have eventually become had they continued to evolve until the present day. With a larger brain, they would have had a shorter neck and a more upright posture. That would have been arrived as a way to better balance the head more efficiently. The vertical posture would also have removed the need for a tail. The legs were modified simply by lowering the ankle to the ground, and the foot was lengthened. But of course, all that's just a thought experiment. The KT boundary event asteroid impact at Chicxulub in the Yucatan Peninsula put an end to that line of evolution. Or did it? The new hypothesis by scientists from Harvard University speculates that some unexplained UFO sightings could actually be signs that these creatures are here. But as Tim Mendham from Australian Skeptics points out, the only thing lacking is any kind of evidence.
There's a story that popped up recently about a recent paper from a team of researchers at Harvard and Montana Technological University. They speculate that sightings of unidentified anomalous phenomena, UAPs, UFOs let's call them, could indicate the presence of intelligent beings concealed on Earth, such as underground, which is the crypto-terrestrials on the moon, which technically speaking is not on the Earth, never mind, or walking among us disguised as humans. Now, these are not particularly new ideas. They talk about all sorts of things thrown up in this article. Obviously, the hypothesis of hidden crypto-terrestrials, underground, underwater, in places where we can't see them and just pop out occasionally. No evidence at all for it. Others are suggesting that these are intelligent species, possibly evolving from intelligent dinosaurs, which is an interesting thought. These developed independently of Homo sapiens, but they're now hiding from us. Now, that's why we don't know them, because they're hiding.
Sort of like Bigfoot.
Others, yeah, I don't know how intelligent they are, but yeah, people have suggested Bigfoot's an alien. UFO sightings, craft and other phenomena, e.g. orbs, appearing to enter and exit potential underground access points like volcanoes. So they're coming in and out, hollow Earth, and flying around and then flying back again to where they were, just to annoy us and confuse us.
I don't know. It all sounds like something R.V. Loeb would write in a thesis.
It does sound like something he would do. It also sounds like something every science fiction writer would do. Remember this TV series called X or V or something, which was about aliens walking amongst us? So that's the other solution, that they disguised as humans and they blend in with us. So honestly, you can find Harvard academics or any academics anywhere. Some academic will support some crazy theory, and I think this one is particularly crazy.
And we've seen a lot of that from Harvard in recent months. So,
we've seen a lot of that from Harvard, yeah. So there's a lot of academics in Harvard, right? So you're bound to have a variety of views, I think. So if you can run the gamut from from one to the other.
Not all views are of equal validity. That's the point.
That's the problem. And so you mentioned it came from Harvard, which is a distinguished university.
It and Columbia are pretty much down the bottom of the barrel now, but they used to be distinguished and reputable at one stage.
Yes, and old. Certainly no substantiation, no evidence, all hypothesis, all conjecture, and stuff that's been done by science fiction writers for decades. So nothing particularly new to see here, folks, except that it's coming from a university.
That's Tim Mendham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.